So welcome back. Today we are discussing about similarity and dissimilarity measures in machine learning. So for example, if there is two items, for example, let's say A and B. So how similar they are? We are calculating using similarity measures. So in similarity measures, cosine similarity, Jaccard similarity and Pearson correlation will be there, whereas dissimilarity is nothing but, so for example, A and B, let us say same example. So how different they are? So how different they are? We are using dissimilarity measures. Okay. So in similarity measures, I will go through the similarity measures. The first thing is nothing but cosine similarity. Okay. So the definition is nothing but it checks angle between two vectors. If A and B are two vectors, okay, it checks the angle. Cosine similarity checks the angle between the two vectors. Okay. So this will be used in NLP, document similarity and recommendation systems. This cosine similarity will be used. Okay. So now moving on to one practical example. So cosine similarity is written as A dot B divided by magnitude A dot magnitude B. So let us go with an example. A dot B is nothing but dot product, and A and B are nothing but magnitudes. Okay, this you need to remember. So for example, I am having a vectors A is equal to, let us say, 2 comma 3 and B is equal to, let us say, 4 comma 6. Just think of, I am having two vectors. So the dot product is nothing but, if A dot B is nothing but 2 into 4 plus 3 into 4 into 3 into 6. So this is what the dot product, right? So 2 into 4 plus 3 into 6. This will be resulting you as 26. Okay. So now we need to calculate magnitude. We have computed the dot product. So if you calculate the magnitude, so magnitude of A is equal to 2 square plus 3 square. Just square it. So it will be resulting root 13. Similarly, if you calculate it for B, the same result. You will be getting root 52. Okay. So now cosine similarity. Cosine similarity is equal to, you have calculated the dot product, that is something but 26 divided by root 13, okay, magnitude of A, and root 52 magnitude of B. If you do it, you'll be end up getting this result, 26 by 26. 676 is the perfect root square for 26, and you will be end up getting 1. So if cosine similarity, if cosine similarity is equal to 1, then we can say it as perfect similarity. Okay, this is what we do in cosine similarity. Now moving on to another subtopic, Jaccard similarity. So which is used for sets, okay, which is used for sets, measures the similarity based on common elements. Okay, so measure the similarity between two sets. For example, A and B are having, let us say, one example I can give, apple, mango, and let us say banana. And B is having, it is for sets, right? So B is having apple, banana, and banana, and let us say grapes. So you can, so what does Jaccard coefficient do is nothing but it will trigger out commons. So what are they common in this example? Apple and banana are the common things, that is nothing but two are common. So total unique names, total unique names are in this set: apple, mango, banana, and apple again repeated, so I will be counting 3, and grapes. So 4 unique names are there in this set example. So what is Jaccard coefficient formula? So Jaccard coefficient formula is nothing but common elements that are nothing but, in our example, apple and banana. So 2 will be our common elements divided by total unique elements. So total unique elements in our example are nothing but 4. So if you do it, Jaccard coefficient 2 by 4, you will be getting, that is nothing but 0.5. So see this Jaccard coefficient, this is how we need to calculate the Jaccard coefficient, and which is used in comparing shopping lists, and let us say one more, I can give tag similarity. So another thing, another use case I can give, text similarity, how much similar our text is. So these Jaccard coefficient will be used in these 3 types. Okay, now moving on to Pearson correlation. So this shows how two variables move together. So how A and B combinedly move together. So if both increase, we can say positive correlation. If one increase and another decrease, we say negative correlation. So there will be one formula here for similarity coefficients for Pearson correlation. The formula is nothing but, I have given one example here, but let me write the formula. R is equal to, R represents Pearson correlation, sigma, okay, x minus x bar. X bar is nothing but mean, y minus y bar by, okay, under root summation x minus x bar whole square summation y minus y bar whole square. This is the formula. So let us, so x is nothing but these values and y are nothing but these values, and x bar is nothing but mean, 1 plus 2 plus 3 by 3. So if you calculate it, you will be getting 2. So y bar is nothing but 2 plus 4 plus 6 by 3. If you calculate it, you will be getting 4. Mean, that is what? So if you substitute all these values, so 2 minus x minus x bar, let us calculate x minus x bar for this equation. Okay, so you will be getting minus 1, 0, 1. You do 2 minus 1 minus 2 minus 1, 2 minus 2 0, 3 minus 2 1. So same way if you calculate for y minus y bar, so the array will be 4 minus 2 2, 4 minus 4 0, 4 minus 6. What will be the result? 2, right? And this will be minus 2, sorry, right? Now you try to multiply them. So you try to multiply them. So minus 1, the first element with the first element, minus 1 minus 2, you will be getting 2, and second element into second element, second elements are 0 into 0, okay, 0 into 0, then it will be getting 0, and the third element into third element, 1 into 2. So that will be 2, right? Now step 4 in this if you do the sum of this equation, 2 plus 0 plus 2, you will be getting 4, right? Now we need to compute the denominator. Numerator part is done. Now we need to compute the denominator, x minus x bar whole square. So 1 plus 0 plus 1 is equal to 2. So if you compute y minus y bar whole square, 4 plus 0 plus 4, that is nothing but 8. Okay. Now you have the numerator. Numerator is nothing but 4. Denominator is nothing but under root 2 into 8. So that is nothing but 4 by under root 16. So you will be getting 4 by 4, and that is equal to 1. This is how Pearson correlation works, and this is nothing but we will be getting positive 1. We can say perfect correlation. Okay. Now moving on to the important topic, that is nothing but dissimilarity coefficients. Now there will be 2 points. So I need to compute the distance between 2 points. That is what Euclidean distance do. I think you people already aware of that formula. D is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula for Euclidean distance. And now just we need to, I am computing one example here. So I am having points A 2, 3 and B 5, 7. Okay, let us say. So x2. So this is, let us say, x1, y1, x2, y2. Now x2 minus x1, 5 minus 2. D is equal to 5 minus 2 whole square. Okay, plus 7 minus 3 whole square. If you compute it, what will be the result? 3 square plus 4 square. Then you will be getting root 25, that is equal to 5. This is the Euclidean distance. This is how we need to calculate the Euclidean distance. Okay. Now moving on to another important dissimilarity coefficient, Manhattan distance. So distance measured using blocks like a taxi in the square city. So using blocks like a taxi in the square city. So if you see the formula for this, x2 minus x1 mod plus y2 minus y1 mod. This is the formula. Same way again, you please try to calculate with the same example. A is equal to 2, 3 and B is equal to 5, 7. Okay, if you compute it, this is x1, y1, x2, y2, right? D is equal to 5 minus 2 mod plus 7 minus 3 mod. If you compute it, you will be getting 3 plus 4. That is nothing but 7. This is how you need to calculate the Manhattan distance. The values are differing, right? So how far they are differing, that is what we calculate in dissimilarity. Whereas how far they correlate, how far they are similar, that is what we calculate in similarity coefficients. Okay. Now moving on to another important topic, Minkowski distance. Okay. Now this is nothing but general distance measure. So here the formula will be like, I will explain here. The formula will be D is equal to mod x2 minus x1, okay, P. Okay, let us say this is P1 and this is P2. This is P1, let us say. Okay, plus y2 minus y1 mod P2. Okay, so P1 is nothing but Manhattan distance, P2 is nothing but Euclidean distance. So in this same example, so we are getting this, right? So for example, I will calculate here. So same example again I am going through, B 5, 7. Now try to calculate the Minkowski distance. So D is equal to So you'll be getting mod 3 by 3 plus mod 4 by 3. I am taking 1 by 3 common. So you'll be end up getting 27 plus 64, 1 by 3. So that is nothing but 91 power 1 by 3. So that is equal to some approximate 4.497. This is how you need to calculate Minkowski distance. Okay, and the last one, which is very easier, Hamming distance. So this counts how many positions are different in two strings of equal length. So for example, A and B are having equal strength. So this calculates how many positions are different in two strings. For example, in this 10, let us say in this 8. So this calculate the 2 as the answer. This is nothing but how many different two strings are different in this equal length. Okay, so the formula for this Hamming distance is nothing but D is equal to number of mismatched positions. So for example, this A is equal to, let us say, 1 0 1 0 1. I am having a string. A is equal to a string 1 0 1 0 1, and B is also a string with the same length 1 0 0 1 1. So this string value is nothing but 5 5. But if you look here, so now compare the positions. This is same and this is also same, but here it is differing and here it is differing. Two positions are differing, right? Two positions are differing. So the difference is the final answer. So D is equal to 2. That is what the Hamming distance. Okay, I think this is clear. If you are facing any doubt or any difficulty in the concept, let me know in the comment section. Thank you guys.